So in the previous session, we started writing code to model the stock market, right? And we saw that there is an equation to represent the variation in the stock, right? So we wrote one function that is called stock prices. Okay, so that code is basically trying to read the initial value of the stock, right, as this. And we have two parameters related to stock, that is R and sigma. Then the end time, that is okay for how many years you want to, right, model, right, that is T end. And the number of intervals you want to say, like daily, you can enter the number of days, right, within this many years, right? So we can actually count the number of days in terms of only weekdays, how many weekdays are present in. If I write 4 years, you can calculate that 4 years weekly, sorry, weekdays, Monday to Friday, how many Monday to Friday will come, and we can search it. Okay, so uh, those are the parameters taken as input by this particular function called stock prices, right? So here we try to calculate a delta value, which is the total years divided by the number of intervals, right? So, and right, we try to calculate a square root of that value, because normally that is what is being used in our function to calculate a w, right? W is a process which w of t normally represented in the form of equation. The w of t represents the process, random process which is used to define uh, the variation in the stock. All right, so that's the w. So we define a time starting from 0 till the n intervals, right? And m is the variable, holds the length of, right, this s naught, how many stocks I want to model. So the s naught will hold initial values of all the stocks. Okay, so I have 10 s naught values, means I should know m equal to length of s naught, which will be 10, which understands that okay, there are 10 different stocks to be modeled. Okay, right? So we create the stock values over here, initialize with zeros. Then this is the actual equation, right? For which there is a function f of k needed, that we calculate here, right? So substitute over there, s of k will be calculated, s of k comma all, indicating that. So for all the columns, kth stock. So m is the length of it, the length of that, indicating that how many stocks you have, right? So k varies from 1 to m. For all the stocks, calculate this, right? So that is our first function, that is uh, modeling the stock price for given years, right? So whatever is the length of year, we can normally, so if you look at the practical data available in the website of related to the NSE or something, right? The stock market data set, whatever we have, it's normally available for say up to 20 years, right? So again, you don't have to depend on that. We can generate here if needed. Okay, so since so that was the first function. Okay, then we wrote another function to plot, right? Whatever function, whatever stocks have been created, we want to plot, means we, this is just a plot function, but we use a plot set function to define the various parameters of the plot, that's all. Okay, which label, etc., right? All the things we try to note here, right? Also, we try to modify our y-axis according to the stock prices. All right, it's actually a simple plot function, but we slightly modified according to our need. The default plot function what we see in Matlab, right? We try to slightly modify that. All right. Okay. So that's what we did so far, till now. So now our intention is we want to write a function that randomly picks the stock's starting price. It will identify the sigma value, that is a volatility, and the drift. Okay, that's my next objective now. And we want to write a function that randomly picks these variables, and it also creates some maybe see I create say 10 different stocks, means I should give some random name at least, right? Practical data will have the name like, okay, this is the Tata Steel uh, price, right? This is the stock price of Reliance, etc. We come to know in the real stock market. In order to identify that, you need a name, right? But you see, now we don't have a name. Let's assume, right, using the stock prices function, I will be able to generate 10 stocks. I have to give some name as well, isn't it? So now I want to write a function, right, which even allocates a name to the stocks created. Randomly, it will generate some name. Let's see to that it generates a three-letter name somehow. Okay, fine. Let's try to do that now. And even we'll try to plot and see how it's going to look like. Okay, so maybe we'll try to create some 100 stocks or something. That's our objective for the day. All right. So let me edit a function called my my stock market. Okay. So in now I want to write this as a function. So function, I have only one output, that is d, right? Equal to my stock market of. So let's define some of the variables here. So what you pass, I want how many stocks to be created. So number of stocks, my first variable. Okay. And I will pass out the, already we defined a variable called s naught. I will pass its mean of that, because normally you see in statistics we don't need a specific data, we just want the mean and the variance value or something. Okay, so we just will use the same thing, s naught sigma value, right? And I need the total duration, so that is t end, we called by the same name. And I also want the number of intervals uh, you want to create. You already have created the data. It's not, now we are not trying to create the data is already created by the other function, which is stock prices. And right now our intention is to model the stock. Okay, I want to give the names to the stocks, etc. I want to do something. Okay, all right, so this is my, so I will start by, so there is a d, right? D is my output, so I'll try to make this d as maybe a class, right? So d dot, create it as s naught, d dot s naught is equal to, so you see I have to use the mean value, that is s naught mean, plus its variance and some randomly generated number. Correct? Because that's how you try to generate the S naught value. Randomly, I should generate the S naught value, beginning price of C. This is the idea, right? We may have, say, if you consider the Nifty 50 index of Indian stock market, there are 50 top stocks, okay, of the of Indian market. All right. So out of all the 50 stocks you have, every stock is not going to have a same initial stock price. Correct? So S naught is the stock price, initial stock price. If you remember, let me go back to the other function. You see here, this is the S naught, right? So how did you generate the stock price? Starting from some S naught. But this S naught should come from some point, right? So when we tested this function, right, I myself entered some S naught from the command window. But right now I cannot do for, say, all the 100 stocks which we are going to create here, right? So that's the point. You cannot keep entering 100 values. So what's the solution? Generate them random, right? Assign some random value. So let's do that. So I don't want negative value, so I'll take an absolute, right? So if you want, you can check what's the meaning of this absolute. So okay, help areas. So you see that this is the absolute value. In the sense negative value is there, it will try to eliminate that. If x is complex, it is going to take the magnitude of that. Negative means negative will be converted into positive, right? So anyway, I'm not dealing with the complex numbers as of now, so no question of taking a modulus here. Negative number generates means it will be converted into the positive, that's all. So I start with the s naught uh, mean value, which is already there. To this I want to add, so plus the s naught sigma value. Okay, anyway, these two are constants. It's not going to be a random number as it is, right? If I just leave it like this, what do? You multiply, right? So rand n. So what is the use of rand n? Do you remember? If you are aware of that, tell me. Otherwise, I'll show you the help. Random numbers. The n actually indicates the normally distributed. Okay. So just look at. Okay, they have not shown example. I directly show you the example. So and n of, say, I'll write 5. It's generated 5 into 5 matrix of randomly generated numbers between 0 and 1, actually minus 1 and plus 1. That's how you can take, right? Random numbers of size 5 cross 5. When you write only one input, it generates only a square matrix of that size. The n indicates it is the normally distributed random variable, random number. But you see, if I try to write the rand n of, say, 2 comma 5, you see 2 rows 5 columns will be created, right? So if you write only one variable, if you pass only one value, it generates a square matrix. Otherwise you specify, right, what rows, what columns size you want, it will generate like that. Now you see, right, now you tell me, I have a question for you. What should be the rand n size inside this? I should write something here, right? What should be the size? Will you generate a square matrix, or you are going to generate depending upon some other parameter, right? So just look at what is this S naught. We already have discussed that this S naught is the starting prices of so many number of stocks which you are going to generate, right? So what should I write inside this rand n? This should be how many numbers of S naughts you want to generate. That's, you can answer that, right? Not in terms of the way. Yeah, so it's, if you want 100 stocks, it means you should generate 100, right? So what I do, if I simply enter 100, that means 100 into 100 it gets created. I don't want that, right? I just want one row, 100 columns. Instead of 100 columns, I'll write the num of stocks. That's all. Are you okay? What you told is right, right? You told 100 because we are taking example of 100. But if you want to generalize the problem, then this is what you are going to enter. Then uh, I need to generate the R value as well, correct? Because I need the volatility and I need the drift value, correct? So let me do the same thing. D is my variable, D dot R is equal to, so if you look at the value of this, right, I should be able to generate the value, right? Again, so again random, right? So what we do, let me generate it randomly. 0.5 into any number you can write, 0.5 into, now you see I'm going to use another function called the rand. Okay, let's rand of say 3. It's going to generate a 3 cross 3, but now you see the difference, it is random between 0 to what you call 0 to 1, right? So rand and rand n has a difference, right? It's a random variable, randomly generates the numbers between 0 and 1. The n is normally distributed. Normal says that you have to have positive as well as negative. That's why this generates a positive and negative. Okay, so now I don't want negative, I don't want a normal distribution, I'll simply use rand. Okay, again how many values? 1 comma number of stocks. I hope this is fine, right? Again, I can simply use the rand function, right? But why I am multiplying by zero point 0.5? Because I want to limit the what you call uh, that this is actually the drift value, right? Whatever r we are writing here, right? It is a drift value. So I don't want the stock value to decrease or increase very fast, right? So if you remove this part 0.5 into, if you try to remove that, there may be a tendency that this rand value becoming equal to 1. So 1 means what it is, right? All of a sudden it may increase, or all of a sudden the stock market fall or raise like that, right? So I just don't want to bring that into my this thing. So I want to multiply by zero point 0.5. So you see, if you get a highest value like 0.999, it gets multiplied by zero point 0.5 so that the value will be reduced. Are you okay with that concept now? So okay, so I'm trying to introduce that. That's why I multiplied by this one. Okay, let's move further. So I created R. I need to create one more value, that is a sigma value. Correct. So this is the D dot sigma should be equal to, now I don't have any restriction. I know that the sigma value, the volatility value is between 0 and 1. So simply I'll generate the random value of 1 number of discounts. Okay, now we need to create, let us say, the stock name. Fine. Let me create a variable. See, S is equal to, this is the stock name actually. So how do you declare an array that contains the letters from A to Z? Uh, can you suggest something? I want to create an array that has all the letters starting from A to Z. Let's say capitals only. Let's try to include only capitals. What should I write here? Like if you want to generate a number from 1 to 10, you will write 1 colon 10. Correct? So it creates 1 to 10. In the same way, now my question is that how do I generate A, B, C, D, E, F, G up to Z? Let's restrict to capital only for the time. Can I write A to Z? Is it valid? Let's check. What happens if I try to write A, B, Z? See? Right? That's all. That's fine for me. So I needed the same thing. So your answer is that I'm going to generate the characters A. See, that's the advantage in Matlab, right? So you don't have to write a very complicated program to do this, right? Right. So A to Z. I don't want to display, so I'll put this. Now from this S, I want to pick up 3. Okay, I want to pick up 3 letters from this, right? And I want to give the 3 randomly picked letters to my stock names as the stock names. Is it okay? So let's try to do that. Say for, right? How many stocks you have starting from 1? Variable not defined. K is equal to 1 to number of stocks. For all these stocks, what we'll do? Okay, let's define another variable. Say J is equal to. So let's see. Do you remember what does this rand I does? We have used in the previous codes as well. That's why I'm asking. So if you remember, tell me what is that rand I? So if I write rand I of say 4, right? What is it? Anyway, this rand indicates it's a random. I for what? I is, can you get, it's integer, right? So you see, if you write rand 4, a random number is generated less than 4. You see, now it is 2. Next, if I enter again, it becomes 2 again, right? Like that. So change it to random number up to 400. See, a number generated getting generated at random, right? So now you see, I want to generate, right? Uh, what is the, see, A to Z means A is 1, say Z is equal to, Z is 26th letter, correct? Starting from this. Now I want to create an array of three different integers. Are you okay? Right, three different integers, but I cannot exceed 26. So you now, by now you understand that if I write 26, one number is created, correct? I want three numbers. So we have a facility like 26, one row, three columns. Just check, randomly generated. Okay, so this means I can try to read 20th letter from this S. That is my first letter of name of the given stock. So anyway, I just want to create three letter words. If you want to go for 5 letters, just make it five. Okay, that's all. Right? If you write it like this, five, right? Oh, sorry. Right. So now we change this to say five, right? So you see, letters have sorry, five numbers are created. I can read these five numbers and the corresponding letters from S. Is it okay? Uh, oh, sorry, S is not created because I just try to do like this. Now you see, I'll show you something like this. See, A to Z is created in S. Okay. Now what I try to do, right? I just try to create another, okay, random integer. Let me put that into a variable called, say, J. J equal to this. Okay. Five letters are created. Fine. Now, if I want to read the corresponding five letters from there, I just have to write S of J. Oh, S of J. So you see, it creates five-letter word. Are you okay? So the name of that particular stock, I can give a name like IPFTG, whatever, right? So this is how it is. But I don't want to do with the five letters now. I'll just go with the three letter, just to keep it simple. I will see S of J. The J will have three letters like this. Simply write S of J. It creates a three-letter name for the stock. Are you okay with this? So I just have to do this. Control C, Control V, right? That actually creates three random numbers, right? So whatever the three random numbers, read the corresponding letters from the S which you had created, so that it becomes your name of the stock. Right now we don't, because it's this is what we are generating, that's why. Okay, so what I do, I try to do D dot, right? I'll call this as a symbol. If you remember, in the previous case we used, you see, there is a word called symbol, SYMB, right? We never use it, but this is how you are going to use it. D dot sim. Okay, I have to write which stock it is. So it is kth stock. Okay, kth stock, all the columns equal to what you are going to assign, S of G. Okay, let me end this. Okay, let's control S. Okay, let us try to run and check whether this is going to work or not. Okay, so here everything. What I do, I I have to enter some of the variables now because number of stocks, number of stocks, let's say I will generate say 10 initially. Okay, that's the number of stocks. S naught mean should be equal to, so mean stock price, let me say 5,000 rupees maybe. S naught, the sigma value, the variance of, sorry, the standard deviation. Say there is a variation up to say 2,000 rupees, right, for every stock. Fine. Then the end time t end is equal to say maybe 10 years I want to generate, and I just want to tell number of intervals. So again, for simplicity, I don't want to say that weekend. Let me include even the weekends. Okay, so 10 years into 365 days, so 3 3650, right? Otherwise, I need to subtract say 56 into 2, that number, into 10, right? So I can do that. Let's try to do that. So 3650. Actually, I can even enter the number here. Let's do the calculation quickly. So there are 3650 in 10 years, minus every year has 2 into 56 into 10. So that comes to be 2530. Okay, so let's consider the somewhat practical data. Right? So that is 230. This is the number of days in 10 years for which the stock market is going to work. Is it okay? All right. Now what I do, let's say this is done. Now I'll run this stock market off so that it creates the uh, stock market. Let me try to. So put it into say X. X is equal to, let's got as a stock itself. Stocks is equal to my stock market of pass everything. So let's try to run this now. So the stocks variable got created here, you see, right? That's a one into one struct. So if I try to open that, you see all the variables we had are created. One is S naught, right? S naught is the initial value of all the 10 stocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see their values are different, right? So again, you can see that there is a R value corresponding to each of the stock. Again, we try to kept it between 0 to 0.5. So you see none of the value exceeds zero point 0.5. Highest is 0.4586. Whatever we want, yes, we could. Then the sigma value, the way volatility of this, again, it's allowed to between 0 to 1. So you can see highest value 0.93, the 10th one. Okay, and you can see the names. Most importantly, we try to create the names. You see 10 names are there, right? Randomly created 10 stock names. Is it okay? Right. Now what I try to do, now I want to uh, okay, let me stocks I have done. Let's try to create the stocks as well. Okay, so I'll create that say S S is equal to, right? I have to, this is just the beginning initial values of the stocks. Now what do you need to do? Create the 10-year stocks of this, correct? For all the 10 stocks you created, try to generate a 10-year data. So I'll put that into S. Okay, so that is, let's use the stock prices, that function. Okay, so you can see here the first function which we wrote here, right? Now I'm going to call this function. Is it okay? So S is equal to stock prices of, so what are the values you need to pass now? You need to pass S naught, R, sigma, T end and N. So, but this, you see here, I have the S naught is in present of D dot S, correct? It's not a directly available, right? I have to use this. So it's present in stocks. So stocks dot S naught, okay? Because inside the stock, you have this S naught. So how do you access this? You see here, it is stocks dot S. It's a structure, right? So stocks dot S naught. That's the first one you pass. Next, you check here. What you want to pass next? It's the R value. So once again, it is present in the same format, stocks dot R. Then what you want to pass? The stocks dot sigma. Let me just verify the name once. So inside the stock, yeah, it's a stock dot sigma if you want to access this. So we pass that. Then anyway, T int and T, these values are actually not present, but I can definitely put that as well if I want. Anyway, I'll directly pass T end and N int. Okay, let me run that. Now you can see the stock market S has been created, including the complete 10-year data. You see, there are 10 stocks starting from first to the 10th row, right? The row number indicates that that's the stock, right? First stock, second, third, fourth, and 10th. So, how many days you asked to create? 2531 days. So, you see, it created all the way to 2531. Yeah, you see, two five. First one, second, third, fourth. You can see a stock is less value, much lesser value, higher value, and so on. Everything we try to model over here. Okay, now we already wrote a function called plot stocks, isn't it? So let's try to plot them. Okay, for which I need to create the time as well. So t is equal to, t is equal to, okay, we create a the linear space, right? What's the size? Starting from 0 till the t end. How many number of pieces you want? That is n number of interval, including the 0. I should add a plus 1. Okay, t is created. Now try to okay, let's try to directly call the plot. Okay, so that is plot stocks, right? What are the variables I need to pass? If you remember, the t should be passed, which is a time, right? Okay, and the stock prices, which variable has the stock prices? The stock price, it is in S, right? So I'll pass the S. See all the 10 stocks, like correct? So we created 10 different stocks. All the 10 stock details, it actually is contained inside this S. right? Now you pass the symbols you want, in the sense the names which you want to, right? Show. Where is it present? Can you tell me the variable name? It is S, not S. Uh, it's inside, I think, the stocks dot symbol. Let's just check. So stocks, there is what is called as a symbol, correct? So stocks dot symb. This is what I want to pass. All right, let me pass this. It's going to take some time to plot properly. Yeah, okay. Just check now. The plot is there, right? So it actually shows on one side what are the different names and what color it is actually plotting, correct? So there is a stock called DOM, which is blue color. You can see the blue color right on the graph, right? So there is one, I think, the red colored one, which is steeply increasing, right? After fifth year till the 10th year, there is increasing. So you see that is also XDV something. So this details are right available. Simply you can call this details. Now actually I can generate 100 stocks. Number of stocks can be 100, and I can definitely run this. So want to change the stock price? Run this S equal to stock prices. That particular command you try to run once again, so that you'll be able to run that again, right? So that the values will be modified. Okay, all right. Now let's proceed further. So far, whatever we try to implement, it is working. Right. Fine. Now, so our next objective is that, okay, everything is ready. So we know that how to generate the stocks, right? And how to give names, etc. We can generate any number of stocks as we want now. Right. Now, our next objective is to build a deep learning system that is capable of predicting the performance of a stock, right? So we develop a deep learning model, and that can be applied to this synthetic data set, which will predict what's going to happen. That's the first thing. Once if once it is done, and if it is if you find that this is really good, definitely we can apply this to our even the real stock data, right? Real stock market data, we'll see that later. Okay, so now you see this stock market data falls under a specific category of functions or signals called as a time series data. In a sense, the variables value depends upon what time you are trying to read that value. Like it's every day, end of the day, like 5 days in a week, right? The closing value of the stock of that day is what we are going to, we assume that we are generating here. Is it okay? So we are trying to generate the stock prices in that way, right? So it actually falls under the time series data, right? So at what time, what is the value? So one of the very efficient deep learning architecture to model that is the LSTM, long short term memory network, which is capable of predicting the future of a time series data. Based, if you give the past values, it is capable of what you call guessing what's going to happen next. right? With some accuracy, not may not be 100%, but definitely. So, right? So you see, anyway, we know that the investments are actually on our own risk, right? But prediction is somewhat really good if you can utilize it properly. Definitely, it's going to be very helpful in the financial planning, right? So, or even the investment decisions, right? So let's see how to build the LSTM deep learning model for here, and how to find its performance. Okay, right. Let's directly move to that. I'll open another file. I'll just close the variables and if I don't want them. We'll create a, say, we'll open a new file by the name uh, my LSTM, LSTM stock market. All right, so it opens a new file. Okay, now, all right, let's try to model like this. So let's define the value. So whatever we have created so far, there is no variables created. Every variable we try to enter through the command window. So this is the main function what we are going to write. Okay. So what we do now? So we close every other window that is present. That's in the first section. We'll move on to the next section and we are going to create the variables now. So n is equal to, so how many days are there? So we'll enter the same number we entered so far. Okay. So because we calculated already 2530 number of days, right? So this is the number of years. Okay, I think we took it as 10 years. All right, then let us try to directly call the function, that is e is equal to, we wrote the stock market value, that is my stock market. So if you remember what are the values you need to pass, let's directly pass them. Number of stocks, uh, right? The mean, sigma, etc. So anyway, right now I don't want to make it complicated uh, by predicting all the 10 stocks. Okay, so simply I'll do only one stock. Okay, so assume that mean is, so I think previously I took 5,000. I'll increase this, maybe say 7,500 rupees is the mean value, and let me assume there is a variance of up to say 4,000, isn't it, with a different number. Okay, go up to the t end and the number of samples, that is n in this case. Okay, pass this, get the stock market in t. For this stock, get the stock price in the next step. So s is equal to, this is the stock value. So I think what was the name? Sorry, stock prices. It should be small. So this will be stock prices of, same thing. Now instead of the stock, it is in D. So I have to pass D dot S naught. Okay. Then inside the D, you have a variable R, and inside the D, you will be having the sigma as well. Is it okay? Pass the time, that is T end, and pass the N. So that creates 10 years of data for the given stock. Okay. Then create a timeline. T is equal to linear space of, right? That is starting from 0. Uh, okay, I can write it 0 comma. So end, end, and it's n plus 1. Okay, so that is done. T is equal to lean space. Then you would go for a plot of that. Okay, so let's look. First, let's try to look this. Anyway, later on, I'm going to hide this. So, plot. What is the name? Plot stocks. Plot stocks. Right. What are the variables? One is a T, the time you created. The stock value is in S, and the inside D you have the symbol SYMD. Is it okay? Let's try to run this. Oh, S not. Where is that? Line number 10. Okay, this should be smaller. Okay, let's see. Visible? Can you see the graph stock which is created? See, the horizontal axis is year, right? Yearly, starting from 0 till 10 years, you can see the variation of the stock, right? So begins with the 10,000 rupees and it reaches maximum value up to, I don't know what's the value, we cannot see exactly, but somewhat see this now, 4,992, right? Around somewhere here. Maybe even the higher value is existing. Okay, right. So this is the value like this. So the name of the stock is QNU. Okay, so okay, so we could create till here. Right. Now in the next step, we try to divide the whole time series data, whatever we have, right? We'll try to split this, okay, into the training part and the testing part. So this is again, already the data is available with us now. I just want the machine to predict that. But before that, let's try to uh, calculate the, first let's divide, okay, into the training and the testing part. That's what is done. So I'll define the L is equal to length of S. So S is already there. That's the stock prices, right? It's going to give, okay, if I try to enter this, you can check what value will come. How many samples you have? 2531, right? That's the total length of the data set, right? That's what is going to be, right? Now I'll try to divide it into training and testing. So how do you do that? The N uh, train is equal to floor value of, right, 80 into 20. Let's divide in that ratio. Okay, so 0.8 is going to be used as 80% into L. So whatever L is there now, it's 80% will be the number of samples in the training. Okay, so depending on this, I'll use the S train. S train should be equal to, out from the S, right? Read 1 to, starting from 1 till N, sorry, N is small, N train. So all the 80% of the samples will be moved to the S train, which are going to be used for the training purpose. Okay, similarly, now you can get S test should be equal to, it is once again S of, after first 80%, remaining 20% should go for the testing, correct? So that is N train plus 1. So the next sample, starting from there, go all the way till N. Not N, I get the less length is L, right? Sorry. Okay, so you see, first starting from 1 till N train, it is S data. That is, S is what? The training data. N plus 1 till the last, it is going to be assigned to the testing data. So this is fine, right? They are separate. Now I want to do a validation. So S, so I need to check that whether my testing, whatever I'm training, is it right, correct or not. So what I do, I'll do S training data itself, I'll try to assign to the validation data, because I cannot give the testing data for as validation. Okay, so that means it will be wrong. So this is the splitting up of my data into the training part and the testing part. Then I try to perform a normalization, right? How do you do the normalization? Calculate the mean first. Mean is equal to, it's a mean of, mu is equal to mean of S train. So take a mean of that. Also calculate the standard deviation. So it's called as sigma is a notation. Sigma is equal to STD, standard deviation of the same thing, that is S. Okay, right? So mu is calculated, sigma is calculated. Now I'm going to call it as a normalized value. So that is S train normalized. This is equal to, so normalization means from the data subtract its mean divided by the standard deviation. So S train minus mu divide by sigma. Okay, you perform the standardization of the training data. Okay, you have to do the same thing for the test data as well. So that is S test normalized should be equal to, do the same thing, that is S test testing data minus the mu value minus its mean, and divide that by sigma. Okay, right. So now what we have done is the normalization of the complete data. That's what has been done. Okay, is it fine? So next session we will start building up the neural network.